Okay, so today what I want to do really briefly is look at complexity of operations. So let's suppose we look at an example like 10 plus 15. Okay, so I'm doing a relatively simple addition question that most of us were able to do fairly easily by the end of second grade, if not that by the end of third grade, for almost certainly. So we look at this operation, and what we should recognize is that the operation itself involves a lot of symbols. In fact, we have 1, 2, 3, 4, 5, 6 symbols that are sort of necessary. And in fact, when we finish the operation, we get our final answer of 25. There's 2 more symbols we have to worry about. So that means we have 8 symbols. So the symbol complexity of this operation is 8. So then we look at the actual algorithmic complexity. The algorithmic complexity is 0 plus 5 is 5. 1 plus 1 is 2. So it looks to me like we were doing 2 operations, so it's an algorithmic complexity of 2. Then there's something else which is kind of important, is that these symbols themselves, not only do they have to be recognized, but there's also a meaning associated with them. For example, this symbol here in this position, this one, actually means something different than were the one to be in this position, so that the location of the one is also important. So we should include that somehow in our complexity, that it's not just the symbol that's critical, but also its location. So I consider that to be sort of a vocabulary of the question. So in that case, the vocabulary of this question, we have got 2 1s that we have to worry about their position, and 2 0 and a 5 we have to worry about their position. Of course, we have this operation we have to worry about, and this line here essentially means equals. And finally, we have the same operation here. Now, I'm going to ignore repetition. So, example, if I understand units position, I'm going to say that any example of units position is 1 in terms of vocabulary. So 1 for units position, 1 for tens position, 1 for equals, and 1 for plus. What actually addition actually means. So that would be 1, 2, 3, 4. So the total complexity of this problem would therefore be 14 units. I don't know what the units are. We're still working that out. Just thinking about this for the first time, really. Okay, so then another idea. What if we do another question which is common, like addition of fractions? So let's say 1/3 plus 1/5. If we do that operation, we'll recognize that we have to, let me just go through the operation quickly. We'll recognize that we have to multiply this by 5, and this by 5, and this by 3, and this by 3, and I'm not explaining why I need to do that yet. We'll get that in a second. 5 over 15 plus 3 over 15 is equal to 8 over 15. So, operations involved in actually doing this question. Well, let's look actually in the same order. Let's look at symbol. We have 1, 2, 3, 4, 5, 6, 7. Sorry, let me go back to the beginning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 symbols. 26 symbols. That seems like a lot. Way more than the first question, right? Okay, next, we look at algorithmic complexity. Well, the first thing I have to do in this algorithm is actually identify that I need a 5 and that I need a 3. So that's 2 operations. Then I need to do the multiplication. That's 4 more operations, so that's 6 total. Then I do the addition. That's another operation. So it looks like about 9 operations total. Then let's look at vocabulary. So in terms of vocabulary, I have to understand what these divisions mean. I have to understand the addition and the equals. I have to understand multiplication. So we've got division, addition, multiplication, equals. Finding the numbers themselves, I would be probably using the lowest common multiple, or at least a common multiple. And possibly, if you are anal retentive about how you return your final answer, you might have to worry about lowest common denominator. Not lowest terms, my bad. those terms. Okay, so this is sort of all of the vocabulary. So we have 1, 2, 3, 4, 5, 6. 6 vocabulary terms. So total complexity looks like it's 15 and 26 is 41. So it should be no surprise that people find addition of fractions much harder than addition of regular numbers, since of course the complexity is greater by an order of 3, assuming that this complexity theory has any meaning at all. Anyway, I'm interested in what you think. Please let me know. I'm sort of just trying out this for the first time and trying to see what it looks like. Thanks.